So I'm going to start recording. This is going to be a video on the practice quiz, explaining all the questions on the practice quiz from 8.1 to 8.2. And on this section, we're adding, subtracting, multiplying, and also classifying polynomials and solving multi-step equations. So question 1 says classify this polynomial. Now, it's going to be the questions are going to be presented in many different ways. Like it may ask you to select from a word bank and just drag and drop first and last name, or it may be a drop down menu. But the bottom line is, to classify this, you need to know your notes right here. Whoops, give me a second. So this is the part that you have to memorize. First name and last name comes from the degree and from the number of terms. Let me get this out of the way. So based on the degree is 2, so that would be a quadratic, and there's 1, 2, 3 terms, that would be a trinomial. So quadratic trinomial is what this classifies as, and that's what you're going to have to select from the drop down menu or from the drag and drop options. Quadratic trinomial. All right, let's try another one of these. Question 2. This is how it's going to be stated on the actual practice quiz. They give you a polynomial, and then they ask you to fill in the blanks for these 3 things. This is the first part of the second question. It says the degree is, what's the degree here? 4. That's right. The degree is 4 because your degree is your highest exponent. There's a power of 4, power of 2, power of 1, and the constant. So yeah, the degree is 4. What is the leading coefficient? Well, you can't tell the leading coefficient until you write it in standard form, where you write it in order. And the first term, when it's in standard form, should be with your highest exponent. So that means that the leading coefficient's what? Negative 2. Be very careful with that. Negative 2 is the correct answer for the leading coefficient. Again, you would have to write this guy out there in the front right here, and then it would be in standard form. Then your leading coefficient would be the negative 2. Okay, and then last but not least, on this second question, the constant is what? 1. Yep, the constant is 1. And I think this is like either drag and drop your values right there, or drop down menu, or fill in the blank. But it's going to be some type of question that asks you for the degree, for the leading coefficient, and for the constant. That's question 2 on the practice quiz. Moving on to question 3. Similar to the previous question, we give you a polynomial. It's all out of order. It's not in standard form, and we need to state whatever they ask. They ask for the constant. What's the constant? 3. That's right. What is the leading coefficient? 5. Leading coefficient is 5, only because you know that if you write it in order, this whole terms are going to be first because that's your highest exponent. That's your degree. And actually, that's the last question. The degree is 4. Okay, the degree is 4. The leading coefficient is 5. So those are your answers for question number 3. It might help you if you're still confused a bit. Rewrite it in order from the highest exponent down to the smallest with a constant at the very end. That's called standard form. You got your 5x to the 4th. You got your minus x to the 3rd. So you got the power of 4, power of 3. Then you got the power of 2, the 2x squared. Then the power of 1. There is no regular x, but there is the constant at the very end. This is standard form, just in case. They ask you to write it in standard form. That's what you would type in. Let's try the next question, number 4. Classify negative 3x to the 4th. And once again, you need to know these notes right here. First and last name, classifying. So what's the first name? It's based on the degree. So that degree is what? 4. Quartic, right? Quartic. What about your last name? It's based on the number of terms. How many terms do you see here? Just 1. So it's a quartic 1-term monomial. So number 4, quartic monomial. And that is the correct answer. Let's move on. This is one of those questions that you guys love. It says select the following true statements. So we need to read each one of these and decide if it's true or false. It says the first name of a polynomial is based on the number of terms. True or false? That's false. That's not true. The first name of a polynomial is based on the degree, right? On the highest exponent, not on the number of terms. That's a last name, right? So don't pick that one. This one, the constant of a polynomial is the number that is in the front of a standard form polynomial? Is the constant the number in the front of a standard form polynomial? No, that's the leading coefficient, remember? So this is false also. Do not pick this one. What about this one over here? The leading coefficient is the number without a variable at the end of a standard form polynomial. No, that's false. What would that be? That would be the constant. That would be the number at the end of a standard form polynomial without a variable, right? Over here, a standard form polynomial is in order from greatest exponent term down to the lowest with a constant at the end. True or false? True. This one is apparently the only one that's true. So that's the one you would select, and you'll get full credit right there. And keep in mind that practice tests or practice quizzes compared to actual quizzes, I just go through each of these statements and change a couple of things. Maybe not on all of them, but on some of them, right? So I may change right here, the constant is the number that's in front. That was false, but maybe I'll change to leading coefficient, which would make it true, right? Anyways, moving on. Question number 6, it's simply subtraction of two polynomials. And I always say, when you see parentheses, obviously you can't do anything in here. You can't add 3 with x squared. But what we should do, if you can't do anything inside of the parentheses, is check and see if there's anything on the outside that we need to distribute in. Like if I had a 2 right here, you'd have to multiply 2 times 3 and then 2 times 3. You'd have to distribute that multiplication of 2. But there's nothing to distribute, which means I could just rewrite it without parentheses. That's going to be 3x squared plus 3. Now over here, I do have this minus sign that I have to distribute. That'll become a negative 2x squared, and that'll become a positive 5. So after I distribute that minus sign, now I combine like terms. Since we know our standard form answer starts with the highest exponent, I'm going to start combining my highest exponent term, 3x squared, take away 2x squared. Do this in your head. What is 3 take away 2? 1. So we're talking about one single x squared, right? And technically, you don't even need the 1. And what about the numbers? We have a positive 3 and a positive 5. That'll give us a positive what? 8. And that's it. And if we check our answer right here, there's our answer, x squared plus 8. And you're going to have to type this in using that math calculator that's on quizzes. Let's move on to the next one, number 7. Simplify. That's just simple, straight up distributive property, right? So we're going to distribute 4 times 3x. That will give us 12x. And then 4 times negative 2, that'll give us a negative 8. And believe it or not, that is the answer right there. You just type in 12x minus 8, you get credit. What? Is this pre-algebra? No, this is algebra. Should be harder than that. Let's move on to the next one. It gets a little bit more fun on this one. There is some distributive property, and there's also combining like terms. We're going to distribute first. We have a negative x that we're going to multiply by 3x. So that's really like saying negative 1x times 3x. So the negative 1 times 3 is negative 3. Okay, so our first part of our answer is going to be a negative 3. And then x times x is x squared. So I hope we understand that negative x times positive 3x, negative 1 times 3 is negative 3, x times x is x squared. And now let's distribute that negative x to the other term, the negative 7. A negative x times a negative 7 is a positive 7x. So I have distributed the negative x. Now I need to just write that minus 5x at the very end. And then after that, combine like terms. And I do have 3 terms. One's an x squared term, and the other 2 are x's, which means I could combine those x's. If I do positive 7x, take away 5x, what do I have? 2x, a positive 2x. And what about that leading term out there? You just leave it there, negative 3x squared. So your final answer is negative 3x squared plus 2x. And if you check your answer right there, that's what you type in exactly like that, and you'll get full credit on that question. So we finally get to a multi-step equation that we need to solve. So I rewrote the equation right here on this notebook paper, and we're going to start by reviewing the steps of solving a multi-step equation. Step 1 is to simplify each side. Now, what does simplify actually mean? It means distributive property and or combining like terms. And it's actually in that order. You distribute first and then you combine like terms. Why? Because distributive property is really multiplication and combining like terms is really adding or subtracting the terms that are alike. And of course, we know the correct order of operations on PEMDAS has multiplication before adding or subtracting. So again, we're going to simplify each side. I'm going to cover up the right side, ignore the right side. I'm just going to focus in on the left side right now. I'm going to distribute 3 times x, that is 3x. Then distribute 3 times 5, that is a positive 15. And of course, I'm going to bring down this minus 5 right here. And now I've already distributed. Now we're going to move on to combining like terms. So out of these 3 terms, is there anything that I could combine? Yes, this positive 15 and that minus 5. We're just going to combine that in our heads. 15, take away 5, that is 10, and that is a positive 10. The 3x in the front simply comes down, and this is what we call the simplified expression of the above, right? This had distributive property and combining like terms. After you simplify it, it's now a nice binomial, 3x plus 10. We still have the equal sign. I'm going to bring that down right here. And now we could focus in on simplifying the right side, okay? So now let's ignore the left side and just focus in on simplifying the right side. So I am going to distribute first, right? Always do distributive property first and then combining like terms. And of course, do we have anything to distribute from the outside of the parentheses to the inside? Yes, we have a 2 right there. Distribute that 2. 2 times x is 2x. 2 times 6 is 12. And of course, we're going to bring down this plus 2, put it right there. And again, we have 3 terms after distributing. And after distributing, we combine like terms. There's an x there. There's no other x's. But I could combine the numbers 12 and 2. So when I combine the 12 with the 2, I'll get a positive 14. A positive 12 with a positive 2 is a positive 14. What about this 2x? We're just going to bring it right down, 2x right there. And here is our new simplified equation. That's barely step 1 on solving equations. Step 2 is to isolate the variable. Think of the goal and get x by itself. So once again, step 2 is to get x by itself on one side, isolate the x, right? Now, if you're thinking, well, I want to get the x by itself, I got 2 x's here. How do I do that? Well, how? How do you do that? To get rid of something, you do the opposite. And what you do to one side, you must do to the other, okay? So if I want to get x by itself on one side, I have x's on both sides of this equal sign. I don't want the x on both sides. I just want it on one side. So I need to get rid of one of these x's. I want to get rid of this 2x by doing the opposite. How do I get rid of the 2x? By doing the opposite. What's the opposite of 2x? It's a minus 2x. And what I do to one side, I must do to the other. So of course I can't subtract 2x's from 10. I have to subtract 2x's from the 3x. So I'm going to put minus 2x over here. Again, what I do to one side, I must do to the other to maintain the equality that exists. So I have 3x take away 2x, which is 1x. Then I have the plus 10, I have the equal sign, I have the 14 that comes down. So I almost have x by itself. Actually, I don't even need to write that 1 right there. But I do need to get rid of this plus 10. So to get rid of the plus 10, I am going to do the opposite, minus 10. And that's going to be off balance. What I do to one side, I must do to the other. So that way I could maintain the balance, maintain the equality. 14 take away 10 is 4. So I do have x equaling 4. That's your answer. That's what you have to type in. And that's how to get full credit. Let's move on. Another multi-step equation. Let's begin by simplifying each side. So I'm going to cover up the left side and just work on, cover up the right side, just work on the left side. I'm going to distribute first and then combine like terms. So I'm going to distribute negative 3 times x. That's a negative 3x. And then negative 3 times positive 4 is a negative 12. Then I bring down this 5. You're going to have a 5 out here in the front. And I really do have 1, 2, 3 terms. And I need to combine like terms, right? First distributive property and then combining like terms. So I could combine the 5 with the minus 12. And I'm going to do that in my head. 5 take away 12. If I have $5 and I owe $12, I'm still going to owe $7. So what I have left is the negative 3x, and I have a minus 7, because having 5 owing 12, you're going to still owe 7. That's as simple as the left side could get. Now let's simplify the right side. So I'm going to cover this up and just focus in on the right side right there. I am going to distribute 2 times negative x is negative 2x. And then 2 times 3 is positive 6. And then I'm going to bring down this minus 9. And out of these 1, 2, 3 terms, I could combine the terms that are alike. There are two numbers, and I could combine the positive 6 with the negative 9. So if I think I have $6, but I owe $9, I'm still going to owe $3. So let me just move this out of the way. Again, negative 9 plus 6, that's going to be a negative 3. And that minus 2x is simply going to come down in front. Now there's an equal sign right here. I'm going to put that equal sign between the left side simplified and also the right simplified side. So now we have this simplified red equation that has x's on both sides. And from here, we need to think about the goal of solving any equation is to get x by itself on one side of the equal sign. So I don't want x's on both sides. I only want it on one side. So I need to get rid of one of these x's. Again, I'm going to get rid of the minus 2x by doing the opposite of minus 2x, which is plus 2x. So I'm adding two x's. I can't add x's with 7s. I could add x's with x's. So I'm going to put the 2x over here underneath the other x. Why do I do that? Because I have to. If I do anything to the right side, I have to do it to the left side in order for the equal sign to still be equal. So anyways, negative 3x plus 2, that is a negative 1x. Bring down the minus 7, bring down the equal sign, bring down the minus 3, and here's your new simplified equation with a variable only on one side of the equal sign. Now let's get x by itself. I need to get rid of this negative 1 that's being multiplied by x, and I also need to get rid of the minus 7. What do you get rid of first? You get rid of the minus 7 first. How do I get rid of a minus 7? You do the opposite, which is plus 7, and of course what you do to one side of the equal sign, you do to the other side of the equal sign. So my new equation is going to be a negative 1x equaling negative 3 plus 7, that is a 4. I'm almost done. I need to get rid of the negative 1 that's being multiplied with x. In order to get rid of multiplication, you do the opposite of multiplication, which is division of that same exact value, negative 1. And of course, what you do to one side of the equal sign, you must do to the other side of the equal sign. So the 1's cancel out, the negative 1's cancel out. I do have just x left over equals 4 divided by negative 1, that's negative 4. And that is our final answer for number 10. And if we look at the actual quizzes, it shows us right there the answer is x equals negative 4. Type it in with no spaces between your terms, and you should get full credit on this question number 10. Number 11, this one's one of the easiest types of questions you're going to see. Why? Because you have a polynomial, you have another polynomial, and you need to just simply add them, which is just combining like terms. Again, I always say if you have parentheses, check and see if there's a number that you need to distribute, which there isn't, or even a minus sign that you need to distribute, which there isn't. So in reality right here, I don't need these parentheses. I'm just going to rewrite it without parentheses. Over here, we have a plus sign, and we all know that if we distribute a plus sign, it's not going to change anything. So I could just, again, rewrite this polynomial without the parentheses. So that's exactly what I'm going to do. I'm going to put a minus 6x to the third, a plus 8x squared, minus 7x. So now we have all these terms that we need to combine. And we want our answer in standard form, highest exponent down to smallest, down to the constant, if there is a constant. Anyway, let's begin with those highest exponent terms. How about this 4x to the third? I'm going to combine that with a minus 6x to the third. That's like having $4 and owing somebody $6. You're still going to owe $2. So minus 2 of those dollars, but in this case of those x to the thirds. Then we move on to the next highest exponent, which is a negative 2x squared with a positive 8x squared. That's like owing $2 and having $8. You could pay off your $2 and you're still going to have 6 left over. So you're going to still have $6, but instead of dollars, we have x squares left over. And then we move on to our x's. Well, we have a 3x here. We have a minus 7x there. And again, thinking of money, you have 3, you owe 7. You're going to owe 4 of those dollars, but in this case of those x's. This is your answer right here. This is what you would have to type in without, well, yeah, actually this is a mathematical question where you type in, you type in the negative sign, the 2, the x to the certain power, then you type in 3, then you got to come back down to hit the plus sign. So be careful when you're typing this in. It has to be exactly like that. As you see, negative 2x to the third plus 6x squared minus 4x. Let's move on. This is number 12, I believe. And again, we have an equation. We're going to simplify the left side because the right side is already simplified. You can't actually subtract x's and numbers, right? So this is already simplified. Over here, we could do distributive property and then combine like terms after doing distributive property. So if I multiply 4 times 1, I will get 4. If I multiply 4 times negative x, I will get negative 4x. And then I bring down the plus 3x. I'm just going to write it right there, plus 3x. And then after distributing, which I already did, now I could combine like terms, the terms that look alike. In other words, the negative 4x, I could combine that with the positive 3x. You could combine x's with x's. Negative 4x plus 3x, that is a negative 1x. Then, of course, bring down the 4 that you see right here, bring it down. You have a 4 minus 1x. Then you could bring down the equal sign as well. Okay, bring down the equal sign. 4 minus 1x equals negative 3x minus 12. All I did was rewrite the right side, just right there. Now I need to solve by getting x by itself on one side of the equal sign, and I have x's on both sides of the equal sign, so let's get rid of one of them. I'm going to get rid of the minus 3x by doing the opposite of minus 3x, which is plus 3x. A positive 3x and a negative 3x eliminate. There is no more x's. What I do to one side, I do to the other side, add 3x over here, and I will get negative 1 plus 3x, that is a positive 2x. Positive 2x. Bring down the 4 that's in front, right? Bring down the equal sign, bring down the minus 12, and there's your new simplified equation that has only one x on the left side of the equal sign. So now we need to think about the goal, getting that x by itself on the left side of the equal sign. I need to get rid of the 4 and of that positive 2 that's being multiplied by x. Of course, let's get rid of the 4 first. How do you get rid of the 4? You subtract 4. What you do to one side, you do to the other side. Your new equation is going to be 2x equals negative 12 minus 4 is negative 16. That's really saying 2 times x equals negative 16. I need to get rid of that multiplication of 2. I'm going to divide by 2, giving us our final answer, x equals negative 8. Again, x equals negative 8. That's what we type in. Let's verify that right here. Answer, x equals negative 8, as you could see. Type that in, and you'll get full credit. Let's move on. Next question is an easy one. It's simply subtracting polynomials, right? So once again, whenever you have parentheses, check and see if there's a number that you need to distribute or a sign that will make a difference when you distribute. Now, if it were a plus sign, if you distribute a plus sign, nothing happens, but it's a minus sign, and that for sure changes all the signs. So what you should do is distribute minus with a minus. Minus, minus, change the plus, so you will have a positive 4x instead of a negative 4x. Then the minus gets distributed over here, and a minus minus will change that to a positive x squared instead of the negative x squared, right? The minus minus changes to a plus. And then the minus gets distributed to that plus 5, which will become a minus 5. So I've distributed the minus sign to each and every term, changing all the signs. Now over here, there is no minus sign, there is no number, so I don't even need these parentheses. I could just rewrite this trinomial without the parentheses. And that's what I'm going to do. I have a minus 5x, a plus x squared, and a minus 4. So I have all of these terms, and I need to combine the like terms. And of course, we want our answer in standard form, which means you want the highest exponent terms first. So I'm going to begin with this positive x squared. And I'm going to combine that. Are there any other x squares? Yes, there's another positive x squared right there. So one x squared and another x squared, that'll give us a total of 2 of those x squares. And then I move on to my regular x's. Well, I have a minus 5x right here with a plus 4x right there. In our heads, we think, if I owe $5 and I have only $4, I'm still going to owe one of those dollars, in this case, one of those x's. And last but not least, we have a minus 4 that we could do with a minus 5. Minus 4, minus 5, you owe 4, you owe 5, you're going to owe 9 altogether. And there's your answer, which is a quadratic trinomial, by the way, but That's your answer, 2x squared minus 1x minus 9. So it seems that this video is getting ridiculously long, so we're just going to stop right here and we will start a second video explaining the second half of this practice quiz 8.1 to 8.2.